Welcome to SurveyBooker Sessions. Tune in to hear from people working in a range of industries and roles to provide you ideas that you can take away and use in your own business. I'm your host, Matt Nally, the founder and director of SurveyBooker, which is the leading CRM and survey management system for surveyors. In this week's episode, we have Vignesh Daas, who's come to join us to talk about building materials and decarbonising properties. So thank you very much for coming on.
Thanks, Matt. Thanks for the invite. So we work in the field of decarbonisation of the built environment. Our focus is to make sure that heavy industries, which are hard to abate carbon, can reduce their carbon, and new innovations can be plugged into the supply chain through startups and through universities and research. We look to fund some of these innovations through grants and through applying our own angel investments, but also we're now looking into venture building, which is putting together talented people in the climate tech and built environment space to accelerate these innovations to market.
Yeah, it sounds really interesting, and I think we're going to touch, for everyone that's listening, on, I suppose, three key areas for this episode. Firstly, this first topic will cover new materials that are coming to market, and I think there's some really interesting stuff that I hadn't heard about before. Then there's, I suppose, the challenges in adopting those materials, and what's stopping people from putting those into place. That's topic two. And then finally, we'll look at sort of what's going on, as you mentioned, around venture building to support the decarbonisation. So it should be a very interesting episode across the three parts. Yeah, I suppose, touching on topic one, the new materials coming to market. I suppose, why do we need to look at new materials, do you think? What's wrong with what we've already got?
Matt, first of all, I mean, this is a key area for building because there are some really mad figures out there about, someone said about building New York cities, like loads of New York cities every 2 years or something like that. I don't know what that phrase exactly is, but one thing is for sure, if you look around us, we have an aging infrastructure in Europe and in the US, but also the global south is developing infrastructure at a rapid rate. But like everything else, these resources are not infinite. They're not renewable. So we will run out of water, sand, stones, and all of those things. So it's just about being mindful and sustainable of how we build and where can we reuse and where can we go circular. So this is why finding alternatives to existing building materials is incredibly important. If we are to still see growth in the next 50, 75 years, it would be critical. And not only from a net zero perspective, but only from supply and demand, and only from and also from a carbon and cost perspective as well. So while we're heavily reliant on things like concrete, which is a great product, there's numerous types of concrete. When I started my research journey 12 years ago, I was looking into low carbon concrete, and now that's something that has become almost a norm. But still, there's quite many aspects to it, so people really don't understand how to specify it. They also find it quite difficult, as in what embodied carbon numbers are deemed as low carbon, and what solutions are there. There's a lot of greenwashing going on around as well. So, old product in a new package kind of thing as well. So this is where it's quite critical for, the industry and for innovators to work together and kind of quash those things from the get-go and talk about what are the cool innovations. For example, we worked with self-healing concrete almost 5 years ago. It's a bacteria-based healing additive, which you chuck. It's a powder, smells like mocha. You chuck it into concrete, and it will help heal the concrete's cracks even when there's a crack. So back then, people thought it's science fiction, and right now it's a commercially available product. So there were lessons learned from that, and it led us to look into more such kind of innovations out there. One of them, like bio-based binder, like BioZero. You've got carbon and CCUS-based products. You've got concrete for change. You've got electric arc furnace residual powder, which is again companies like Vision, Cambridge Electric Cement. So there's multiple new innovations coming into this space, which building how we are right now will change in the next 5 years, if not earlier. Some of these innovations are already plugged into the supply chain, and it's a matter of people like you and I talking about these things on podcasts, so that civil engineers and structural designers are aware that these cool innovations exist out there.
Oh, definitely. I think one of the stats that we looked at before recording this was the construction industry is responsible for 37%, and I haven't got the reference for this, but 37% of greenhouse gas emissions. And we'll come on to venture building later, but only 5% of global venture capital is directed towards that. You've mentioned like some new materials, which sound really interesting. I think potentially in a moment we can start to look in a bit more detail at sort of what those 5 things are. But how do they actually reduce the sort of carbon impact? Is it that they're more efficient to construct with in the first place, or they're more greener to extract and use, or is it that they, like the self-healing concrete example, it means you don't have to replace concrete as quickly, therefore it sort of has a longer lifespan, for example? Do they all operate in very different ways in reducing sort of the carbon impact?
Sure. I mean, the stat that you mentioned is from United Nations report on the environment.
Oh yes.
And that's a critical stat that we use in almost all of our literature, because for an industry that amounts to that much carbon emissions of the whole world, we do not put that much time and money into it to actually go and help it improve. It's easy to blame, it's hard to solve. One key aspect of what you've mentioned is cement. Cement is a very heavy carbon emitter, only because you burn limestone at a very high temperature in order to produce cement. So the cement product in itself is an amazing product. It's been used since the Romans. So it's hard to replace something that's been used for so long and has been proven as to be such a good product. It's a matter of how do you produce it where it doesn't cost the planet that much environmentally. So there are innovations out there, and what you've just mentioned is, I think there's a common consensus in the industry now. So there's no one solution. There's no one, let's replace cement or let's replace steel, which are high carbon emitters. It's about how to design them efficiently, how to apply them efficiently. So, do you need a SEM1 cement, which is a high grade cement that you use for, residential tall buildings or for infrastructure, or can you replace it with, I don't know, a bacteria-based binder or electric arc furnace slag in pavement tiles, or to start with, right? Eventually, we can then prove the case studies and bring them onto structural elements. So there's that transition. That transition needs to happen layer by layer. We can't just, there's always the danger of what we saw in AAC in schools, right? All of a sudden, in the 70s or 80s, they were all, specified everywhere, and it didn't work out that well. So for that, innovation has its own journey. For example, I can talk about self-healing concrete. And when we brought it to the UK, it was a spin-off from Delft University in Netherlands. When we brought it to the UK, we had to prove that it's non-toxic. We had to get it insured. We had to prove that the bacteria only works when there's a crack in the concrete and when the water gets in touch with the capsules. So we had to prove all of that, which it does take time. But however, there are early adopters out there. There are infrastructure agencies who are keen on getting these things on board. You can now go and see how this product is used in breakwaters in Cornwall, and it's helping marine flora and fauna to grow on these concrete products. So
Interesting.
we utilize the approach of greening the gray. Concrete doesn't always need to be
No.
gray and dull. It can be very, very, very useful, and it's just finding ways of how to make it useful. It's the same with other embodied carbon based products. I think the challenge is finding the gaps in the supply chain, supplementing the gaps, and I do not agree with the term disruption. The moment a startup or an innovator comes and says it's a disruptive product, it's a bit of an orange flag. I wouldn't call it a red flag. I'd call it an orange flag, because if it's disruptive, how do you stop a multi-trillion-pound industry on the planet, which is used to its ways, or do you come and augment it with your product and give them another route to market, give them another way to sustainability, and give them another way of specifying something different which could work out for everybody. So it's almost like, you've got your bread aisle. Do you want to still have the same bread every day, or are you going to go and look at different alternatives that might be, a morning tea breakfast bread or something different? But it does give you that option. I think we are looking for more options rather than tech that will stop what is already happening. I think we're looking for more options for, the market is so big, the need is so big. We're not only building bridges, we're building bridges, retaining walls, roads, pavements. You mentioned residential earlier. You've got bricks, you've got insulation. There are materials out there which are replacing plastic insulation with mycelium, which is a mushroom based product. So yeah, plenty out there, but it's about finding the place of the innovation in the supply chain.
Yeah, there's a lot of interesting stuff to pick up on there. I think one of the ones around disrupting, you're right. It's you're not going to persuade industries that have got processes in place and machinery in place and tools or whatever it might be, training, um, to completely change everything they do. It needs to be a supporter or a supplementer, I think, rather than a tears everything apart. You're going to get more engagement with whatever it is, if it's a material, a tech product, or whatever. I suppose with these new materials, how much opportunity do they have to reduce that 37% of the sort of construction industry sort of impact? Because how much comes from the material aspect? How much is machinery and power used on site, and all that type of stuff? Do we know that type of split at all?
Yeah, I mean, to give you a bit of a broader idea about that, I mean, cement and concrete, I mean, they're probably 80% of that 37%. So eight of the entire world is about 25% of that 37%, isn't it? So you look at those numbers and you go, okay, there's a lot of innovations going into that one sector. But the other half, I would say, would go into energy, like you've mentioned, energy on site, energy usage. We started looking into companies with new energy storage methods. You know, people almost always focus on, oh, we haven't got energy. We've got plenty of energy. We just don't use it as efficiently as we can. So, which is why there's price fluctuations, which is why there's issues. The other week we were talking to a company which can increase the life of mining vehicles. Those large mining vehicles. They can increase the life of the battery by 50%. That's a massive change, with a tiny innovation coming up for one of those vehicles. So you don't have to use diesel, you don't have to use fossil fuels. You can use renewable energy batteries, and you can even increase that battery life. So there's the layered approach that we've been looking at. That 37% is not just, there's no one solution for it. There's no let's replace cement and it will all be good, or let's replace all diesel generators with batteries and that will be all good. So all of these innovations, as like with anything new, you've got to try it, and then you've got to figure out where it fits into the problem solving matrix. Another key aspect, I think we are different as an industry to to fintech or to something like that, is we are a safety driven industry. Safety is paramount. You ask any engineer, any surveyor in this industry, we are all driven by safety. If we don't know how safe the material or the process is, it probably won't be used, because there's no room for error. I've heard many people who pivot from fintech and move into construction tech, and they feel like they know how this market will work, which is a fair assumption on paper. But when you go into practical challenges, it will be about, yes, your product is great, but we would need this to be proven on a construction site, which, as you know, doesn't have that much, space in this project management schedule. You got to fit it into that, and you got to train people while they're working on site. So there are those challenges, and to implement an innovation into that project management cycle is incredibly hard, without compromising safety. So while construction gets a lot of stick for being, oh, you're risk averse, rightly so, because a civil engineer or a structural engineer or a quantity surveyor makes a mistake, it's probably not going to end up well. So yeah, let's not break things and try again. Let's just be careful about how we do it. It's about finding where exactly in that project management can we fit in a tiny bit of innovation and show the benefits, so that the industry can gain confidence from those trials. Equally, pilot trials are not an actual business case. Pilot trials are meant to give you an opportunity, a window to showcase your innovation. So take it if you get one.
So yeah, it's a very good point that you've raised there. It's easy to label an industry as risk averse, not trying anything out. But as you say, actually, when you measure the consequence of that risk of trying something out going wrong, it can be quite catastrophic. We end up with the next rat concrete, because we've just taken a punt to see what might happen. That's also not going to be a good label on the other side. So it's and you're playing with lives and stuff then. So yeah, no, it's a very interesting perspective on looking at that type of label. I think my final sort of question, I suppose, around this topic before we move on to topic 2, is it possible to go through the different materials just in a tiny bit more detail, just explain what they are? So for example, like what is waste valorization, and sort of where does it get used, and same for like composite materials and bits and pieces.
Of course. I mean, it's a massive topic.
Oh yeah.
It's you go into building materials, everything around you is made of. I mean, I can see bricks right behind you, so
Yeah.
there's always something that we know that we have used. Waste valorization is quite interesting. It's not a new concept. It's been around for ages. It's using. I mean, waste is probably not the right term anymore. It's using byproducts from other industries as a feeder product in another one. So I think you can take, for example, the most common one that you'd hear in the construction industry is blast furnace slag. So it's from steel manufacturing. So you can take that residual powder from steel manufacturing, and it's got cementitious properties. So you can replace cement partially with this powder. So essentially, you don't have to go. So let's say we replace 100 kilograms of cement with this powder, which is already a byproduct of another industry. We don't have to go and mine and burn 100 kilograms of limestone or whatever the required amount is. So that helps save that amount of nature and just uses the waste from this industry into the other one. So that's just one example. And there's multiple examples of that. There's coal, there's steel, there's biomass, then even glass, for example, right, or wind turbine blades, etc. So you can take multiple byproducts from different industries. I mean, wastewater, paper sludge. There's incredible amount of work. But what I like about this topic is someone really senior in the industry always says, if you come to me with a solution that can help take away 4,000 tons of something, it's not really useful. If you can say to me that you're going to take 4 million tons of it, then it's useful, because the processes are in such a way that small incremental disruption is actually a problem, because you're changing your day-to-day operation to trial something which is not proven to then be to be more sustainable, which in essence is actually not that sustainable, because you've tinkered and tailored and changed methods of operations. So embodied carbon might be less, but operational carbon won't be. So once the theory is proven that this waste is worth 4 million tons or 40 million tons or something like that, then you're very much welcome to go and trial that. I mean, something new that I am really excited about these days is electric arc furnaces, and they have their own new slag forming, right? And there are companies out there. I mean, there's one we're working with now called Semvision. They're a Swedish startup. And working with Breakthrough Energy Ventures, which is funded by Bill Gates, is their venture. It's Microsoft's venture capital fund, if I'm not wrong. But yeah, definitely funded by Bill Gates and Jeff Bezos and all of those guys. And they are looking into this area, and you can take away new electric arc furnaces, which are a new method of manufacturing greener steel, and you can again use that product into cement replacement or partial cement replacement. So it's a great way of utilizing different products into the supply chain of another industry. I mean, you must have heard about biochar, for example, right? Biochar again is from feedstock and biogas
Okay.
and all of that, and you can use that for soil stabilization. You can use that for
Mm.
in concrete. So there's a company called Ecolock in Germany who do some of that. So yeah, this topic is incredible because I mean, to be fair, it's my background, so I get excited about it.
Yeah, absolutely. And then, and is that a similar thing that feeds into sort of like the bio-based technologies and nature-based designs and stuff like that? Are they sort of fairly interlinked, the different types of materials?
They are, but equally, the biotech based product. Again, I'm really passionate about those because starting off with self healing, that's where we looked at, bacteria doing incredible work. Then again, last year we worked with BioZero. They are a startup who are incredibly exciting because they can grow concrete. Right, they can literally grow concrete. It's a bacteria-based binder which reacts with water and stones and whatever else, and it will just you won't need any cement. You can literally bind different, so you can use it anywhere on the planet, right? You can go to Japan and you can use their local products and you can bind it all together with this bacteria, so you don't need to go and mine limestone and cement at all. So and you can make this in Mars maybe, or so the scope is incredible. The idea behind is incredible. So it always, I don't know if you're a Mission Impossible fan, but it always reminds me of Mission Impossible 2 when they used to grow stuff in the lab in Australia. So I get really excited about those kind of things. So
Definitely.
yeah, I think that's kind of the future, and that's where it's heading. So as civil engineers and surveyors, we need to look at those aspects and see where they're going and keep a tab on their testing and see how we can incorporate those in, I don't know, in tiles internally, or in facades and things like that, which aren't necessarily structural. And if these things can go past fire regulations and things like that and prove their safety, I mean, they're incredible innovations to stick into a residential building or a commercial building.
Definitely, definitely. And my final question then around the types of materials coming, carbon capture and storage, is that potentially, and maybe this is an unfair comment or wrap around it, but is it more of a reactive solution rather than a proactive? The other ones where we're looking to reduce carbon emissions by changing the types of materials we're using, is that more just of a reactive solution, um, rather than changing the inputs, we're just sort of trying to store up the output?
I think it's a very much required innovation almost. So it depends on the application of it. So, for example, if you're a large cement manufacturer, um, and you can retrofit your plant with a piece of equipment from a startup or a researcher, and that piece of equipment allows you to lower your emissions by any percent. Let's say I'm even in the favor of 5%, right? If it lowers your emissions by 5%, your production is much more efficient and lower carbon. And I think that's where the innovation starts really. And I think it's incredibly important that something like that happens. And credit to cement companies, they're all doing it, and a lot of them are doing it successfully. There's a Peak District cluster. If your viewers might be interested in that, it's a bunch of cement companies trying to figure out how to incorporate this tech into their supply chain. And I think there are again someone like Vision. They've got their own technology which can be retrofitted onto existing cement plants or electric arc furnaces to then make it further lower carbon and produce materials based on that technology. So it's an exciting space. But if you did say that you're going to capture carbon from the air and build big machines and all of that, I don't think a lot of people would be very, very keen on that because it's high capex and low output. Might as well just plant some trees that might do the trick a bit better. I'm not an expert in that space, but retrofitting cement plants and building material plants with carbon capture technology is probably a great way forward.
Interesting. I suppose before we wrap up this topic and move on to sort of the challenges of adopting new materials, if you got say two or three sort of top materials that you think are worth looking into as a surveyor or someone in the construction industry. I'm guessing self-healing concrete would be one of them, because it's a very interesting one to read about when I was looking at it. But have you got 2 or 3 that you think, if you're going to go and learn about some materials, have a look at these ones?
Sure. I mean, one thing I know is getting quite popular is limestone fines. It's an incremental product. It's been around for ages. But also electric arc furnace slag, because that will be the next thing, because all the cement steel plants are being moved towards that. So how do you incorporate that, and what are the embodied carbon values, and what's the price point? Who are the suppliers? That will be an interesting one. Something as common or as simple as basalt reinforcement, because basalt reinforcement instead of steel can be used in many applications. And funnily enough, basalt is the same price or cheaper sometimes as compared to steel, and it's lighter. So, contractors on site or small residential contractors, they should be looking at that. They should be looking at making pavements and tiles and paving tiles and stuff like that with these kind of innovations, which might allow them to build quicker or more efficiently, less time on site, which means greater safety as well. So smaller incremental innovations, rather than going into absolutely disruptive innovations immediately, might allow contractors and designers to kind of figure out how do you incorporate innovation into your day-to-day project management schedule and your supply chain.
Definitely, and it's about all the different parts adding up together to create an impact, rather than just one silver bullet. So that's been really interesting. So I think if you enjoyed listening to the new materials coming to market, join us for part 2, where we're looking at the challenges of adopting them.